Okay, let's take a look at number 19. So number 19, I'm going to go ahead and set up a table of values for number 19. I've set up my standard 5 x values that I'm going to try. We'll start off with some basic points, the y-intercept. We've got 0.5 to the x. To the 0 power, that's just going to be 1. And to the first power, that's going to be 0.5, or 1/2. Okay, so those two are pretty straightforward. We've got a y-intercept and a very first point. This one, as you can see, is going to swoop down. We're getting smaller and smaller. If I square 1/2, I get 1/4, or 0.25. On the other hand, if I raise 1/2, and it might be useful to think of this as 1/2, if I raise 1/2 to the -1 power, that's just getting its reciprocal. That's dividing by 1/2. And if you remember from keep, change, flip, we keep, so we 1 divided by 1/2, keep 1, change to multiplication, flip 1/2 to 2 over 1, 1 times 2 is 2. And then keeping with the pattern, we will now be keep, change, flip with 1 divided by 1/4. 1 divided by 1/4 is 1 times 4 over 1. So we've got 4 for that point. All right. Now, another way of thinking, of course, of 1 divided by 1/4 is how many quarters go into 1? Well, 4 quarters go into 1. So we'll go ahead and plot this on Desmos. And get rid of all of this business that's already there. Okay, and there's our function. We are swooping down and to the right. Okay, and that is 0.5 to the x power. And it fits. Yay. All right, now we've got g of the x, and g of the x has a bunch of other things going on. One thing, we've got an initial value of 3. And we're adding 4 to the overall function. So if I take these x values, or these points, I'm going to be modifying my y values for each one. So we're going to start off with the modification of 1. Okay, so if x is 0, then I'm going to be 0.5 to the 0 is 1, but then that's going to be times 3. And if we just focus on this part of the function, let's deal with that first. So this is going to be 3. 0 will give us our initial value. This is the a, and a, b to the x. Okay. And then if x is 1, then I'm going to have, x is 1, then I'm going to have 0.5 times 3. So 0.5 times 3 is going to be 1.5, or 3/2. Okay. And then I'm going to be doing 3 times this one. 3 times 1/4 is going to be 3/4, or 0.75. Go back here. So I'm just tripling all my y values. So 0.5 to the -1 was 2. So I'm going to have to multiply that times 3. So that'll be 6. And that's going to be times 3 again. So that'll be 12. But I'm not done. All I've dealt with is this part of the function and the transformation. I still have one more thing, which is this +4. This +4 is just added to my y value. On each one of these, my y value is going to go up by 4. So this is going to become 16. This will become 10. All of them are just going up by 4. And this becomes 7. And this becomes 5.5. This becomes 4.75. And we plot this on Desmos. And we'll see if it matches the function. So there you have it. I've got all my points right here. They are stretched out a little bit from before, and they are lifted up by 4. Okay, so these two are 3 times as far apart as these two. So from here to here, I went up by 2. From here to here, I go up by 6. Okay, from here to here, I go up by 1.5, whereas from here to here, I just went up by 1/2. So that's 3 times as much. And then I lifted everything up by 4 from that. Okay, so let's plot it 0.5 to the x again, but we're going to multiply that times 3. Okay, so we get that first of all, and then we add 4 and it matches. Okay, so one thing you might have noticed is very early on we could approach it one more way. Okay, so I go here. Another way to start with is we could start with 0 as our x value. So I've got, this is my y-intercept. We'll just start with the very basics. I've got 0.5 to the 0 is 1. So that's just a 3. So that's a 3 plus 4. So I can get my y-intercept pretty quickly. And I can get my x equals 1 output. So that's 1.5. That's 0.5 times 0.5 to the first power. So 0.5, so half of 3, or 1.5, plus 4 is going to be 5.5. So I can quickly get a plotting of my initial couple of points, which are here. Okay, so I get these 2 points, and I can pretty quickly start to get the feel for the shape. But I do recommend getting at least 3 other points using our basic -2 to +2 inputs. Okay. Having said that, let's take a look at number 20. All right, so number 20, we've got f of x equals 0.6 to the x. I'm going to rewrite that as 3/5 to the x, because I think it's useful to think of it as a fraction in this case. I'll do it both as a fraction and as a decimal, so you can see how both could be done. We're going to start off with setting up an initial table of values. You should do this on your own and then come back to the video, pause it, and come up with your table of values and then see what I did. See if that worked out. All right, assuming you have come back, I'm going to go ahead and do the table of values 2 ways. I'm going to do the table of values based on 0.6 and also based on 3/5 as the version. So we already know probably that if x is 0, function equals 1, because 0.6 or 3/5 to the 0 is going to be 1. We also know that if x is 1, then y is going to be 0.6 or 3/5, because that's the same as 1. So that's the same as 0.6. Okay, now if x is 2, so we're squaring 3/5. That's 3/5 times 3/5. That's going to be 9/25. 9/25. I'll put that down here because that's the fraction one. Okay. Or I could do 0.6 times 0.6. 0.6 times 0.6. Well, 6 times 6 is 36. I have 1 plus 2 decimal places. So that's going to be 0.36, which is the same as 9/25. I quadruple the denominator to get 100. I quadruple the numerator to get 36. That's 36 over 100. And now let's go back here to -1. Okay. Now I find it easier to figure this out using the fraction version myself. So if x is -1, that's raising 3/5 of the -1. That's the same as getting the reciprocal of 3/5. So that's 5/3. Now this is one of the where you're going to see why I don't really want the decimal version. 5/3, you're not going to be able to write precisely. If you try and type it in, you're going to be slightly off because you're going to be rounding it. So 5/3 will work out better for you. That is 1 2/3 or 1.6 repeating. Okay. All right. Let's go over here and move that over. Move it over so it's a little neater there. Okay. Then 2, -2 is going to be easier to work with as well. That's going to be the reciprocal. So 3/5 to the -2 is the same as 5/3 to the +2. So I'm going to square 5 and square 3. So 5 squared is 25 and 3 squared is 9. So once again, I'm going to have a repeating decimal in my decimal version. So 25/9 is the same as 2 7/9. Or so 2 8/9. Let me think about that for a second. No, 2 7/9. 2 7/9. So that's going to be 2.7 with the 7 repeating. Okay, you're not going to be able to write that in Desmos. So you better write that as a fraction or else it's going to be way off. So let's go ahead and plot it in Desmos. Delete all this other business. You can probably tell in my video making and the way I talk, I've been influenced by Sal Khan because he loves the word business in his videos. Okay, so there's my points. Okay, label them if you like. Okay, see, we ended up with rounded versions of these, but these are actually using the fraction version, so they're not actually in the way they're plotted rounded. So we've got 0.6 raised to the x power, and that works. The tricky bit is where we go over here and deal with this. So I'm going to stick with the fraction version for this first of all. Okay, so we use those basic inputs. Okay, but the thing is, we're going to have 3 times the impact for our inputs. So I'm going to dial this back a bit. So if I don't need, so, well, first of all, 3 times 0 is still going to be 0. So 0.6 to the 0 power will still be 1. But I do have an initial value. So that's going to be 2 times 1. So that point's easy to get. Our y-intercept will be very easy to get. Then let's do this one. Well, if I'm doing 0.6 to the 3x, that's going to be 3 times 1. So that's actually going to be to the 3rd power. All right, 3/5 of the 3rd power is actually going to be 27 125ths. I'm not liking that very much. So instead, I'm going to use a different x value. I'm going to use an x value that would let this 3x be 1. And the x value that would let that 3x be 1 is 1/3, because 1/3 times 3 is 1. So now I can get my same y output of 3/5 here, but then I am still going to be doubling it because I've got an initial value of 2. So it's going to be 2 times 3/5 or 6/5. Okay. If you want to write that one as a decimal, that's legit. That's going to be 1.2, and that's okay. You won't have to worry about repeating stuff. All right. Now let's do the same thing. Instead of 2, I'm going to make it 2/3 so that 3x gets me 2, because 3 times 2/3 is 2. So I'll have the same output for 0.6 to the that I got for 0.6 to the second power, which was 9/25. But then I'm going to have to double it because I've got this initial value. So 9/25 becomes 18 over 25. You could get a decimal version of that, quadruple the numerator, quadruple the denominator. You'll get 72 over 100, and that's 0.72. But I wouldn't do the decimals for these over here. I'm going to change, once again, I'm going to change these two to their x value divided by 3 so that I get the same exponents. Okay, so I negative 1/3 is going to get me the same output for 0.6 to the 3x as I got for this over here. So I'll have 5/3, but I'm doubling it, so it's 10/3. Okay, and then to the instead of to the negative 2 power, I'm going to do the negative 2/3 power. So 3 times negative 2/3 is negative 2. I'll end up with the same thing I got over here of 25/9. Okay. So I've got 25/9, except I'm doubling it with this initial value. So it's actually 50/9. Now in Desmos, Desmos will be very happy with graphing this. If you want to plot this, I wouldn't plot it with a decimal, and wouldn't plot it with a decimal. I would plot it with a fraction. And you are, of course, hand graphing, so you will be eyeballing some of these fractional values. I will go ahead and make this into a mixed number, so it's a little easier for plotting. So 50 divided by 9 is going to be 5 and 5/9. So that's 5 and 5/9. 10 divided by 3 is going to be 3 and 1/3. So there you have your points. So if I take this, copy it over into Desmos, I've got this set of points. The big things that are happening, there's two things happening here. One is all my x values are 1/3 their distance from 0. So everything has been squished towards the y-axis. And that's because of this 3x thing. So this 3x thing caused all my x values to squish towards, become 3 times as close to the y-axis. This times 2 stuff, though, caused all of them to double their distance between each other. So from here to here so I've got this point and this point. That's a 2/3 distance. But from here to here, that's a 4/3 distance. From 2 to 3 and a third is 1 and a third, or 4/3. So 2/3 distance, but squished in closer. And so 2/3 distance here. Here I've squished that x value closer, and it is a 4/3 or twice the 2/3 distance. So this 3x got things squished closer by 3 times, closer to the y-axis, and this times 2 made the vertical distance of them 2 times as much between each point. So let's just confirm that I got this right. So that's 2 times 0.6 to the 3x, and it works. And both of these are swooping down and to the right. All right, I hope this has been helpful. Please feel free to send me an email asking me any questions you have about any of this. I'll be happy to respond or try to create a video that addresses your concerns. I hope this has been helpful for you this weekend.